Recall that the slope of the secant lines form a difference quotient, and we have two different formulas, just changing out the variables. One is the slope of the secant lines are f of x minus a over x minus a, or we could do it using the formula f of a plus h minus f of a divided by a plus h minus a, which just simplifies to h. Here we don't want h to equal 0, and this is for some value of x at a. Okay. Now these two expressions for calculating the slope of the secant line we'll illustrate these on the next page. But both of these methods for finding the slope of the secant line are valid, and the choice will really just depend on the ease of the calculation given the situation you're looking at, and that'll become apparent by the problem. So this is the case where we have f of x minus a divided by x minus a. And we can see this in red there, the slope of the secant line. Now, however, as we move these points, x, as we move that closer and closer and closer to a, what will happen is these secant lines will become flatter and flatter and flatter. Okay. Until, let's undo this so you can see it, the point gets so close here that we'll actually be able to form the tangent line. And this is what this is saying then. Furthermore, the slope or the secant lines themselves approach the tangent line to the function at a. Okay? And the secant lines represent the tangent line is the limit of the secant lines. And this is the key point here. The limit of the secant lines is the tangent line. So that's our big takeaway here. The limit of the secant lines is the tangent line. And it works also if you're using this definition with a plus h. In this case, you pick some a, and then you pick some distance away from it, h. So the next point is a plus h. Now, as you move this point closer and closer and closer to a, really what's happening is that h is getting smaller and h is going to 0. And so that's how this definition comes about. And since the slope of, that's true as well. Since the limit of the secant lines is the tangent line, then we can come to our formal definition about the tangent line. And again, it's in two different, using our two different notations. It's just, we say then that the slope of the tangent line is the limit as x approaches a. From here, x was approaching to a, okay, of the difference quotient. Okay. Alternatively, we could use the other formula, and now we're letting h go to 0, but again, it's of the difference quotient.